This is Learning Assessment Problem 10.7. The problem-solving strategy here is that of magnetically coupled circuits. The problem requests us to determine the impedance seen by the source. We'll call that source voltage V sub S. And let's first label some quantities on the circuit. This will be the impedance Z sub S, which we're seeking. Let's label two loop currents, I1 and I2, and this parallel impedance we'll refer to as Z sub P. Then the approach that we'll use is that this Z sub S impedance which we're seeking is equal to the source voltage V sub S divided by that I1 mesh current. So we'll begin by doing a KVL equation summation around the mesh current I1. And we'll have minus V sub S plus 2 minus J1 plus J2. These are all impedances times the current I1. And then we observe that the current I2 enters the dotted terminal of the second inductor, which is mutually coupled to the first inductor. The same as I1's entering the dotted terminal, so we'll have a positive mutual inductance term of J1 times I2, and that sums to 0. Or this equation is obtained when we rearrange terms. Now we'll consider the expression for that parallel impedance. Z sub P is equal to the minus J2 ohms times J1 ohm, a parallel combination, minus J2 ohms plus J1 ohm in the denominator, or Z sub P is equal to J2 ohms. Now we can do a KVL summation around the loop I2. So here we have again the mutual coupling term, just like we had in the first KVL expression. This J2 term here is that Z sub P equivalent impedance. And then we can combine terms here and write this expression as. So now we have the two equations and the two currents I1 and I2, and we'll proceed to apply the matrix equation solution process to determine the expressions for the currents, particularly the current I1. So writing the preceding equations in matrix format, we'll have now the determinant delta of the impedance matrix is equal to 2 plus J1 times 2 plus J4 plus 1, and that is equal to 1 plus J10, which in polar form is 10.05 at an angle of 84.29 degrees. Now the solution for the current I1 is equal to, which is equal to 2 plus J4 times V sub S divided by that delta expression. Now we can write that the impedance that the source will see, Z sub S, is equal to Vs divided by this current I1, which we've written the expression for. And this is equal to delta divided by 2 plus J4, which is equal to, where the denominator is the polar form of that 2 plus J4 expression, or Z sub S is equal to 2.25 at an angle of 20.86 degrees ohms.